and welcome back. In this video I'll be showing you how to read and write using the binary files. So a binary file could be anything that's not a text file basically, so video or an image like a JPEG is what we're going to be using in this example. So if you use the same code as what we had previously, we're going to change bits of it around. And so the file we're going to open is called keyboard underscore bokeh, or Bocker, or whatever you want to call it, .jpg. And we're going to read that, but it needs to be read binary, so we do RB. And now also we're going to save it. We're not going to save it as a text file, we're going to save this as image2.jpg, and we're going to write it using WB for write binary. So what we can see here is that we currently are reading the buffer size as being 100,000 with the buffer limit of being 1,000,000. We can delete that, we don't need that, we're not limiting it, we're going to write the entire image, otherwise it'll be corrupted. And then we've got the while length of buffer, so that's all exactly the same. So what we are going to do, I'll quickly show you what the image is that we're going to be looking at. First things first, the image is a JPEG file. It's 3 megabytes ish, and it's 4,608 pixels by 3,072 pixels. It was taken on my DSLR camera back in December, sometime near Christmas, and so this is all of the exposure details and all the colour profiles and so on that was taken with the camera. So these details will not actually be resaved because we aren't copying over the special data in which we are. Sorry, it will be sent over because we're copying all of the binary data and not just the actual image data. So all of the data will be sent, including all of the dimensions, the camera make, the colour profiles, everything that was saved on it. If you want to actually access this file and any other of my images which I've taken, you have complete access to them all, and you have the complete right to actually access and use them for whatever you want, as long as you don't sell them. You can go to my Google Plus page, and there's a link in my profile on Udemy, and also on. If you want to use any of my images for any reason, such as to experiment and play around with this idea with, or even to use them in projects or whatever, you can go to my Google Plus page, which is gplus.2/BowersBros, and you'll be able to find them all on there, and they're all Creative Commons, so you can use them as you like, as long as you don't sell them. This one, which we're using in this example, will actually be provided for you, and it looks like this. So this is the image in which we are going to be using. It's just a picture of my laptop basically, but it has quite a lot of data within it. Like I said, it's over 4,600 by 3,000 pixels, so it's quite a big image, and so it allows us to have quite a large data set to go on, which is turns out to be about 3 megabytes roughly. So what we can do now is, if we save this and if we run this, you'll see that we got a lot of dots, and then if we refresh over here, and if I open up this, now you can see that it's been rewritten completely. Now this turns out to be quite a bit bigger, so there we go. The reason why it looked bad on the screen is because the window is actually bigger than the recording area. However, the image is pixel perfect, it's saved exactly the same way, and if I open up the properties, you can see it's got the same number of actual bytes, so it's an exact replica. Now there is one more thing which I should mention, which is if we didn't actually write this to a file, if we just read it, if I was to just treat this as a normal input file, so actually what I'll do is I'll create a new file. So what I'll do is I'll create a new file, go over here and create new file, and I'll call this file2.py. Now what we're going to do here is we're going to treat it the same way we treated the other ones, which is where we read it as a text file, and you'll see that we actually get an error if we do try that. So file is equal to open, and we'll go, it's called keyboard.jpg. Now if we save that, we need to do the for line in file print line and is equal to empty string. So if we run that, then we get this something called a ASCII decode error, or a Unicode decode error. And what that means is that basically it's an image file and it's trying to read it as a text file, which obviously it can't do. So now if we add it to read as binary, we're using RB, and if we run that again, then what you get is this string here, which is sort of hexadecimal, I think. I'm not entirely sure what it is. Basically, that is the image data that's been saved. It's still being read. That's the data that has been saved in terms of an image, and if you were to save that as a text file, that is what you would get. You wouldn't get it, or if you sit to write it without it being written in binary, that is what you'd be writing. So when you write in binary, that gets converted back into pixels. So that is essentially what we are reading and writing, is a series of what looks like strange characters, which actually is the image data all encoded, and I think that's in base 64. I'm not entirely sure on that, so don't quote me on that, but that is basically the image data as it's being stored in binary. So thank you for watching, and I will see you in the next video.